So you remember from the introductory chapter that we saw how to set the class path when running a Java application. And we saw how the class path affected how the application run. And we have the same code here. So here, if I go Java -cp to set the class path, then say classes/lib/helper.jar, and then run com.pluralsight.main, then the code should work in exactly the same way. We see hello from helper. And if you remember, what is happening here is that Java is looking in the classes directory and in the helper.jar file to look for both the com.pluralsight.main class and in this case the com.manteaser.helper class that's used by main. We also know that if the helper.jar file doesn't exist, then this code won't run. So if I rename helper.jar to something else, so I say something like move lib/helper.jar to lib/foo.jar, and then rerun the application, then the application won't load. So in this case, we get our famous java.lang.no class def found error when it's looking for com.manteaser.helper. And that's because helper.jar isn't on the class path. So as well as the class path, there are two other locations that Java loads its classes from. If we look at my computer, we'll see that I have Java installed inside the program files directory. So I have program files, Java, JRE18, build 25 at this point, and there's a lib folder. And inside the lib folder, we have rt.jar. And it's rt.jar, this is the Java runtime.jar that contains the base class library, if you like. These are the base classes that Java uses. So if I name this to rt.zip, and then look inside this file, we'll see that inside here we have things like java.lang, and then if I do a search, we'll find we have, for example, the string class. So this library contains the core Java classes, and many of the classes that we use inside our application will be loaded from here. So this is, if you like, the first port of call for any application that wants to load Java classes. So let me rename that back to jar. You'll also notice that inside my lib directory here, I have this other directory called ext. Inside the ext directory, this is the Java extensions directory, are also a set of jar files. And in here, for example, we have things like the Java cryptography extensions. So these are Java classes that are used by many, many applications, but aren't part of the core libraries in Java. So they're not part of rt.jar, but we'd like to ship them along with every other application that we're going to use. Any class, any jar file inside the extensions directory will be used or can be used by our application. So for example, if I take my helper.jar class, so here's my helper.jar class, and we know that this currently works. If I do com.pluralsight.main, then the application runs. If I go and find that jar file and delete it and place it, for example, inside a temporary folder here, so we can see that's now gone from the lib folder, and try and run the application again, the application now fails. If I now take that same jar file from the temporary folder and move it to the JRE extension folder, so this is now part of the extension classes, and go back to my command prompt and try and run the application, then the application now works again. And what's happening now is that com.pluralsight.main is being found in the classes folder. lib/helper.jar doesn't exist, and instead it's finding helper.jar inside the extensions folder. And just one more test, if we go back to our command line and delete lib/helper.jar completely, so we're just using classes, then again the code still works as we'd expect. There are also a couple of things to note here about the extensions directory. It's also used by the Java-C compiler. Now, we have to remember in this case that there are two extensions directories possibly, one used by the Java runtime environment and one used by the Java SDK. and these could be in different places, the appropriate one will be picked up depending on which copy of Java you use. That's where the extensions directory will be found. So for my Java runtime environment, the extensions directory was in program files Java JRE18025libext. For my JDK, I'm running it from my home Kevin J Dev Java folder. And inside there, that has a JRE folder that contains a lib, that contains an extensions, and in here I've placed helper.jar. So from my command prompt, I can run javac minus source path source /com /poodleside /main.java. That will compile main.java using the helper.jar file from the extensions directory. If that jar file didn't exist, then my main.java would not compile. The other thing to know about the extensions directory is that you can also set it explicitly. So we can run Java, again setting the class path to classes, but now setting the extensions directory to c:\lib. This could be any location. And again, if we try and run this code, the code fails. If I take my helper.jar and place it in this lib folder and go back to the command prompt and run the command again, then the application works again. So we're allowed to set the extensions directory wherever we want to as part of running Java. So what about the built-in classes? We've seen that we can use the extensions directory to contain libraries. So we've put helper.jar inside the extensions folder. But in my code here, I've now created a new string and passed it the text hello world, and I simply print out that string. If I go back to my command and compile that code, so again we're just saying compile the code from the source path source and output it to classes, and that should compile okay. And I take that code and run it, again just specifying a class path of classes, we get hello from the helper and we get hello world. So the string class is coming from java.lang.string, and that's part of the standard Java runtime. Now suppose we try to write our own string class. We can write our own string class and put this into a package called java.lang. So here inside Sublime, if I do file, new file, and then do a file save as, and go to the sources folder, and inside here we'll create a new folder called Java. Inside there we'll create a new folder called lang, and inside here we'll save this class as string.java. So inside my string.java file, if we create a class and we call public class string and save this, we put this in a package. So we put this into the java.lang package. We'll save it, and then if we go back to our command prompt and compile our code, we'll find that the code tries to compile. So it tries to compile the string class. So it does find java.lang.string on the class path. So in this case, our class doesn't have the correct constructor, so the compilation fails. So how about we modify the code so that it compiles? So here we just do string message equals new string, no parameters. In my string class, we have a default constructor. Then I've also added this helper method, so getValue, that simply returns the value 42 here. And if I go back into main.java and put in a call to getValue and just print out the value we get back. And if I make sure both of these are saved, and then go back to the command prompt, and here we can compile the code. And the code compiles. So we have this weird string class with a call to getValue that's compiled correctly by javac. However, as soon as you try and run this, so we just do the same thing as before. We do java-cp classes, and that will point at the classes folder that contains the java.lang.string and com.pluralsight.main, and try and run the code, then the code now fails. And now it fails with a method telling us that the getValue method can't be found on java.lang.string. So it seems that while javac will happily compile any class, so java.lang.string, when we try and run this from inside Java, something fails. So here we get this no such method error, as the loaded java.lang.string class doesn't have a getValue method. And the loaded class is coming from rt.jar. So what happens here is we have something called the bootstrap class loader. And the job of the bootstrap class loader is to load the bootstrap classes. These are the main classes that make up the Java runtime. So it's the bootstrap class loader that loads classes from rt.jar. So one last thing to be aware of, we can actually also override the bootstrap class paths, at least on the Oracle Java virtual machine. So if I do java -x, this will print out extension flags that we can pass to the Java runtime. And if I scroll back to the top here, we'll see that some of those flags include boot class path. So we can say -x boot class path and specify a set of directories, and the Java VM will look in these directories for the path, /A to append directories to the built-in set of classes, and /P to prepend a set of directories to the built-in set of classes.